Advanced course, episode 5. Text is just one way to interact with AI. Voice and vision are where the next wave of products is being built right now. Today, you build an AI that can hear you speak and see what you show it. Let's go. Welcome to episode 5. Most AI applications are text in, text out, but your users do not live in a text-only world. They record voice memos during commutes. They take photos of whiteboards after meetings. They screenshot error messages and receipts and handwritten notes. If your AI can only process text, you are deliberately ignoring most of the real world your users live in. Multimodal AI means working with multiple data types: audio, images, and text, sometimes all at once. Today we cover the two modalities that unlock the most immediate real-world value: voice and vision. Let's start with voice. A production voice pipeline has 3 stages. Transcription converts spoken audio into text. Processing passes that text to your LLM or agent, which generates a response. Synthesis converts the response text back into spoken audio. For transcription, OpenAI's Whisper is the gold standard. The large V3 model achieves near human accuracy across a wide range of accents, audio qualities, and background noise levels. You can run Whisper locally for free with the OpenAI Whisper Python package, or call the Whisper API endpoint for approximately 1 cent per minute of audio. The API version is faster and requires no GPU. For real-time transcription, streaming transcription as the user speaks rather than waiting for a complete recording, Faster Whisper is a community re-implementation that runs 2 to 4 times faster using C-Translate 2 under the hood. With streaming chunking, you can begin processing transcribed segments while the user is still talking, cutting your end-to-end latency significantly. For voice synthesis, OpenAI TTS is the simplest integration. 6 voices, adjustable speed, 2 quality tiers, and an API that mirrors their chat completions endpoint. For more expressive, natural-sounding synthesis that does not sound robotic on long passages, 11 Labs is still the leader in audio quality. The difference is clearly audible, especially on technical content with unusual terminology. Now, Vision, GPT-4o, and Claude 3.5 Sonnet both accept images directly in their API calls alongside text. The mechanism is straightforward. Encode your image as a base 64 string, include it in the messages array as a content block with the type set to image URL for OpenAI or as a source object for Claude, and the model reads the image alongside any text you include. The capabilities of these vision models are genuinely impressive and improving rapidly. They can read text in images, including imperfect handwriting, at reasonable quality. They can describe charts and graphs and explain what the underlying data shows. They can identify objects, interfaces, and code. They can compare 2 images and describe what changed between them. They can pass receipts, invoices, and forms without you needing an OCR library. 2 important caveats. First, vision models make mistakes, especially on small or dense text, complex financial tables, and detailed technical schematics. Building confidence checks and human review fallback for anything high stakes. Second, image tokens are expensive. A full 1280 x 720 image can cost 800 to 1200 tokens with GPT-4o's vision encoding. Downscale images before sending when full resolution is not needed. The practical use cases for vision are everywhere right now: receipt and invoice passing without OCR preprocessing, whiteboard and meeting note transcription. Screenshot-based bug reporting that AI can actually diagnose. Form digitization, product photo analysis for e-commerce, medical image routing for triage systems. Here is a complete voice assistant pipeline in under 50 lines of Python, import sound device, and SIPI for audio capture. Import the Whisper API client, import your LLM library, import the OpenAI TTS client and sound file for audio playback. The record function captures audio from the default microphone for a specified number of seconds using Sound Devices recording function. Save it as a WAV file with SciPy. The transcribe function sends the WAV file to the Whisper API. The API returns a text string, your transcript. The think function sends the transcript to your LLM with a system prompt defining the assistant's behavior. Returns the response text. The speak function sends the response text to OpenAI TTS. You can select the voice and specify the output format. The function saves the resulting MP3 and plays it with sound files play function. Wrap all four in a main loop: record, transcribe, think, speak. You now have a voice assistant. The full round trip latency is Whisper API call, typically 1 to 2 seconds. Your LLM call, which varies by model and response length. OpenAI TTS call, typically under 1 second. Total 2 to 5 seconds end-to-end for most interactions. Acceptable for a turn-based assistant. For near real-time conversation, you would stream the LLM output to a streaming TTS endpoint, which cuts perceived latency in half. Now, the vision demo, here is how to analyze a photograph of a whiteboard with Claude. Read your image file in binary mode, encode it as base64. Build your messages array with a user content list, a text block asking your question, and an image block with the source type set to base64, the media type set to image JPEG, and the data set to your base64 string. Call the Claude API exactly as you call it for text. The response contains Claude's analysis of whatever you showed it. Your challenge: build a voice memo processor. Record a 2-minute voice memo about your current project. Talking points, ideas, blockers, anything. Pass it through Whisper for transcription. Then pass the transcript to an LLM with a structured output prompt that extracts a 1-paragraph summary, a list of action items with owners and deadlines, and a list of open questions to follow up on. Output clean JSON. This is a genuinely useful tool you will want to use again. Voice, vision, multimodal pipelines. You can now build AI that interacts with the real world, not just typed text. Episode 6 is about turning everything you have built into a product people actually pay for. See you there.